Great. Well, thanks again, Eric, for the opportunity to speak about my own experience with the Bioptogen OCT imaging. I am a corneal and refractive surgeon at Bascom Palmer Eye Institute, and I'm the medical director of the Ophthalmic Biophysics Center. I first became interested in anterior segment OCT imaging because of the types of corneal surgery that I perform. This is the first case, a 33-year-old male with keratoconus, and we were able to image many of the steps of the surgery, sort of to help us understand what exactly is going on and where and how we can improve this procedure. So this is a scan preoperatively of a patient with keratoconus, and here you can see that we can get volumetric data as well. So this is sort of real-time imaging. On the right-hand side, we have the surgeon's view of the cornea, and we can scan the cornea with really quick acquisition time, obviously non-contact. Then we can magnify our view in any one of these cuts and see what our thickness is of the cornea and identify what part of the cornea is the thinnest and where. In the DALC surgery, we perform partial thickness trephination, and this is after partial thickness trephination. And again, here you can see that we still have a fair amount of stroma left behind before we're left with Descemet's membrane and endothelium only. So here we have the scan, and here we have the high magnification where I can see, I still have 192 microns left before I hit the Descemet's. So this is a tricky part of the DALC surgery and what I call the blind part of the surgery, where a needle is introduced into the residual 192 microns of stroma, and the goal of this part of the procedure is to insert the tip of the needle so that it's just pre-Descemet's membrane without perforating through Descemet's membrane, inject air to get a detachment of Descemet's membrane and endothelium. And as you can imagine, this part is quite delicate and somewhat blind, so wouldn't it be nice to have an imaging modality intraoperatively where we could be assisted in this part of the procedure. So here we have a high magnification of the needle into the stroma in this portion of the procedure, and again, this is something that we're studying under IRB approval, not yet indicated with a Bioptogen device, but something where I believe that there's a need in my particular field. So then we have the next step where we inject air, and here we can see that there's opacity or intense signal, and as you can imagine, after this portion, when we look at the cornea, our view is obscured. So we really can't tell by looking at the cornea after the air is injected whether or not Descemet's is detached or still attached. Again, here we go with our volumetric scan, and here again, because of the depth of penetration and sort of optimizing our working distance, if we actually scan deeper into the anterior chamber, we'll be able to get a sense of whether our Descemet's is detached or still attached. Here we have dissection of our residual stroma, and again we have a beautiful detached, intact Descemet's membrane. And again, we can confirm that not only visually, but by our OCT imaging, and we can again drop a cursor and measure the uniform Descemet's membrane and endothelium that we have at this point of the procedure. Here is after the stroma of the donor tissue is sutured into place, and on top of our recipient Descemet's and endothelium. Here, if we have irregularity, we may want to fill the anterior chamber with air or saline to help get rid of these wrinkles on the posterior Descemet's membrane. This is a case of a patient who underwent attempted DALC, where there was a perforation through Descemet's membrane, aborted DALC, and penetrating keratoplasty. And this is an interesting OCT image where you can see that there's actually ruptured or penetration of the Descemet's membrane. And here when we obtain the OCT imaging, you can see that all looks good up until about here. And now we can see that, in fact, there begins to be this perforation and scroll of Descemet's membrane where there's penetration and rupture of Descemet's. So in that case, we proceeded with penetrating keratoplasty because of the rupture. And here's a high magnification, nice view of the rupture and scrolled Descemet's membrane. So the results of imaging with OCT of our DALC procedures were that we were able to visualize with OCT the preparation steps, the trephination, depth, and needle location. We were able to monitor the depth of the stromal dissection during preparation and visualize graft attachment to the Descemet's membrane. How about DSEK? DSEK surgery, again, as I mentioned, is a common procedure for endothelial cell replacement. And one of the problems with DSEK surgery, and one of the most common complications that we see, is graft detachment postoperatively. So how can we make this procedure better and minimize that complication? Well, here is a preoperative scan of a patient with Fuchs dystrophy. Here you can see that the cornea is quite thick, the epithelium is thick, and then if you actually measure Descemet's membrane, you can see that Descemet's membrane is thickened as well, along with gutata on the endothelial surface. Here we have a DSEK donor tissue. So with DSEK surgery, we strip the diseased Descemet's membrane and endothelium. We remove it from the recipient eye and we replace it with a donor endothelial cell layer and Descemet's and some stroma. So this is the scan of the Descemet's, of the donor tissue inside of the eye. And here it's free floating in the anterior chamber. And here you can see it sitting on top of the iris. We can measure the thickness of the donor tissue. And after the donor tissue is placed and air is filled into the eye, you can see also with the OCT we can confirm postoperatively that our donor tissue is attached without interface fluid. So we think that if the patient has interface fluid after the surgery, that perhaps that's a risk factor for detachment postoperatively. And here, again, we can measure. Now we have a much thicker cornea because, again, we've placed our donor tissue in the eye. So imaging of DSEK with supine OCT allows us to look at the condition of the donor endothelial lenticule and monitor the adhesion to the recipient. Finally, DMEK, or Descemet's membrane endothelial keratoplasty, is what's hot in corneal surgery these days. So rather than replacing Descemet's and endothelium with a DSEK lenticule, where we have stroma involved, now some surgeons are starting to replace only Descemet's membrane and endothelium without any donor stroma attached. As you can imagine, harvesting Descemet's membrane and endothelium alone can be tricky. And this is a study that we did at Bascom Palmer looking at using OCT to help us with our DMEK graft preparation. Here we have a donor cornea that's flipped upside down, so we're looking on endothelial cells, and the technique is that we're going to insert a needle just pre-Descemet's membrane, inject air, and try to get a nice big bubble or detachment of Descemet's and endothelial cells alone. So here is our first attempt. Here you can see that the needle is visualized here. Here we have the needle profile and the needle tip. So again, it's a beveled needle, and here you can imagine the bevel and the tip of the needle. So remember, now the endothelial cell layer is here, and we're still quite far. So using this image, we can say, all right, we're going to repass or advance the needle location 2 to push it closer towards Decimase membrane so that we can get a good big bubble once we inject air. So now we're much closer to Decimase membrane. We can inject air and we get this nice big bubble. So endothelium and Decimase comes off, and here you can see it very, very nicely on the OCT. So I'd like to thank my collaborators at Bascom Palmer who are working on this project and the support that we've received, and thank you for your attention.